In this part, we are talking about math in Java, which include how to do calculations, use built-in math class, and apply common math functions in your program. So by the end of this part, you will know how to handle everything from simple arithmetic to advanced functions like square roots, powers, and random numbers. So let's jump right in. So Java can handle all the basic arithmetic operations, okay, using operators. For example, you might want to add, for example, you might create a variable here. You might want to create a variable here called a, and then you set it to be equals to 5, and then another variable b, and then you set it equals to 10. So you can perform arithmetic operations. For example, you can create another variable called c, and then you store a summation of a and b using the arithmetic operators like the plus. Okay, so you can perform the addition like that. Okay, you can perform it like that. So we know that the addition just adds the numbers. Okay, the plus sign just adds the numbers, and the forward slash gives the quotient. Okay, and the percentage will give us the remainder. Okay, and the remainder, this remainder is good. I'm talking about this sign. So if we have this one like d, let me name it d, and then we do something like this. We do b, and then the percentage b, and then the percentage a, like that. This one is going to give us a remainder. So d is going to contain the remainder after division of 19, okay, by 5. Okay, so if both numbers are integers, Java performs integer division, okay, which is decimal, which include dropping the decimals. Okay, so if you want a decimal result, you should use a double. Okay, you should use a double. So and let us take a look at the math class. Okay, so Java has a built-in math class that gives you access to tons of mathematical methods. No need to import anything because it is part of the java.lang. Okay, so let us start. Let us take a look at how we can use it. So for example, let us delete everything here. Let us delete all those variables that we have created. So let me use sort to shorten the time that I'm going to use typing, but as if my computer stopped as is freezing. I thought there is a code snippet for that, but as if the extension has not yet started, that helps me to use those shortcuts. So system.out.print.ln. So let us return the square root. So in order to system, so here I forgot system. So here, in order to get the square root of a certain number, we can use the math.square, okay, .square like method. Okay, so we can do it like this. So math.square squared like that. Okay, the square, then inside here we should pass in the number. Okay, as you can see here, this method takes in a number. Okay, takes in a double. Okay, so we can pass in like 4 like that, or you can pass in 4.0 okay, whatever you want. Okay, so if we go here, as you can see here, they are telling us that it is incompatible, but it is right. So let us try to get compile, as if my computer is slowing. Okay, so let us compile. So when we compile, we get 2. So the square root of 4 is 2. Okay, and if we try for 9, we are going to get 3. I'm very sure of that. Okay, so if you want to get the power of that number, you can use the method which is which is called the POW for power. Okay, so and if we try to hover over it, as you can see, method POW in class math cannot be applied. No. I want something like let me. So here we need to provide two arguments. Okay, so as you can see here, this one takes in we require the double. So here, as you can see here, we need for this POW. Let me go back here. I want to show you for this POW takes in 2 arguments. So if let me reduce on the sides, as you can see, it takes in 2 arguments, and the first one, it takes in the number, and then it takes in like the number, okay, the number and the power, okay, to which that number has to be raised. Okay, so for the power, so 1 2 1 4, and then the power let us specify that 2, okay, to power 2 like that. So if we save like that, and then we try to compile, and then compile, let us wait, and then we run. As you can see, 4 to power 2, we are going to get 16.0, okay, because it is a double. Okay, so we get 16. Okay, so we can also do another operation, another mathematical operation using a certain like other methods. Okay, for example, we can get the absolute value, and even we can round off numbers. Okay, we can round numbers. Okay, so for example, let us get the absolute value. Okay, so for the absolute value, the ABS, there we use the ABS method. Okay, and that one returns the positive value. Okay, so for example, if we had here, let us get now instead of creating a variable, let us just use it like this. So let us use ABS absolute, this one, and then we need to take in a double. Okay, so what we are taking in, let us take in a -2 like that. So, and we see what it is going to return. So if we save, and then we come down here, and then we compile, let us wait, and then we run. As you can see, we get 2. Okay, so it has returned a positive value. Okay, and that is its purpose, that is its use. Okay, so we can also round off numbers using the round method. Math.round, we can change like that, math.round, and this one takes only 2. This one returns the nearest whole number. Okay, and we can only, so here let us take in point, let us take in that one. So let us do like that, and then we save and then compile. Let us wait, so let us run after compilation. As you can see, so we have returned the nearest, we have rounded off to the nearest whole number, which is 3. Okay, so we have got 3. So we can also do another one. We can also instead of rounding up, we can round down. Okay, so for example, let us use in order to round down, we can use what we call the math.flow. We can use the flow method. So this one is going to round it down, okay, to the nearest, to the let me compile. Let me first compile. You will see the output as I'm explaining. Okay, so it is going to round it down. Okay, so if I compile, so as you can see, we get 2. So we have rounded down. Okay, so by default the rounds up. Okay, so it does this one, it does cell. Okay, it uses the cell. So by default the rounds up. Okay, so it uses cell. Okay, it is the same as using the cell method. So if we save that one and then we compile, we are going to see that we are going to get the same output that we got previously when we used the round. Okay, as you can see, we get 3. Okay, but this one is returned in form of a double. Okay, not in form of an integer. Okay, so for the round, we return it in form of an integer, and then for the cell, we return it in form of a double. Okay, so if we try to hover over this cell, as you can see, this one returns the smallest or the closest to the -infinity. Okay, so double value that is greater than, it returns a double value that is greater than or equals to the arguments and is equal to a mathematical integer. Okay, so that is it about the cell. Okay, so we can take a look at other methods. Okay, like the minimum, the maximum. For example, let us get the minimum and then the maximum. So for example, here let us use it here. So for the minimum, what if we want to get the minimum between 2 numbers? So we have 26, and then we need to provide 2 numbers. We have 26 and then we have 100. So let us return the minimum number. So if we save, let me copy this one, copy, then we go into the next line and then we paste there. Then this one is going to return us the maximum number. So the maximum. So the second line, we are going to have the maximum number. Okay, so if we compile and then we wait for seconds and then we compile, as you can see on the second line we have the maximum, which is 100, and on the first line we have 26, which is the minimum. Okay, so we can also do another operation like getting a random number. Okay, we can generate a random number. Okay, so for example, let me do something. Instead of getting the maximum, let me use the random. random. So for this random, we can provide something. So let me use the random. So for this random, when I try to hover over it, as you can see, returns that this one is going to do something. This one is going to return a double value, okay, with a positive sign greater than or equals to 0.0, okay, and less than 1, okay. So it is going to return it in form of like, it's going to return something which is between 0.0 and 1.0, okay. So I think we are going to get some numbers like 0.5, 0.3, 0.2, 0.1, like that. So if we save, let us see the first random number that we are going to get. If I try to compile and then wait for some few seconds and then compile. So as you can see, we get this random number. So if we run the program again, as you can see, we get a different number. If we, as you can see, we get different numbers, okay, random numbers, as you can see, but they are all between 0.0 and 0.1, okay. And that is it. So we can also use trigonometric functions for those who want to, who love trigonometry. We can also use trigonometric functions, okay. So these ones are mostly used when you are building games, okay. So let us try to use trigonometric functions. For example, we have another one. So you just you have got the concepts, guys. You have seen how we can use them. So and for this case, if you want to use the sign, you have seen that in order to use a certain method, we just need to use math dot then the name of that method, okay. Then a set of parentheses, and then we pass in what is required, okay. So if that method does not require us to pass in some arguments, then we leave it empty. We leave the parentheses empty, okay. So for example, it is the same as saying that here, when we are working with trigonometric functions, we use them in the same way we have been using, okay, other mathematical method, okay, method, okay. So let us have cos. For cos, we just use math.cos, okay, like the math.mean, okay. So for the cos, we use math.cos. Then here we pass in, so math.cos, let us pass in like let us pass in the angle. We need to pass in the angle. So this one takes in an angle. So let us create our angle here. Let's create our angle. So for this one, let us create a double here, a double here, and then let us name it the angle. Then here we need to provide the angle. So this one, the angle, we need to convert them to radians, okay. We need to convert them to radians, okay. So we use, in order to convert them to radians, to convert our angles like 45, 90, 180, 270, 360, 450, like that, okay. We need to first convert them to radians, okay, because this one, because these are cos and sine, these trigonometric functions, they are going to take in radians, okay, values that are in radians. So dot 2, so here we use math.2 radians. As you can see here, we can convert to degrees or we can convert to radians, okay, as you can see here, okay, the options that we have, or to radian, degrees or to radians. So but here I want to use dot 2 radians, okay, dot radians, and then here I need to pass in the angle. So the angle, let me choose 45, okay, 45. So with 45, after converting it to radians, then we can come here and then we pass our angles in our angle in radians, okay, here in cos. So if we save, and then you can try with your calculator, and then you get the cos of that angle, cos of 45, okay. I think we are going to get the same answer here. So if I try to compile and then I run, as you can see, the cos of 45, let me get my calculator here and I see. So the cos of 45, yeah, as you can see, that is the output. Cos of 45 is 0.7071, okay. So let us try with the sine, okay, sine. So for the sine, we use sine like that, okay. So let us try to compile, and then we run. Let us wait for some few seconds and then we run. As you can see, we get the same output because sine of 45 and cos of 45 are the same, okay. So let us try to change this angle to 90, like that, and then we try to compile. After compiling, let us run. as you can see. So for the sine of 90 is going to give us 1, okay, and the cos of 90 I think is going to be 0. Is it 0? Let me change this one here to cos, like that. If I save and then I try to compile, okay, after compilation let us run. So let us run. As you can see, so for the cos of 90, let me calculate using my calculator. Cos of 90 is going to give us a 0, but here we are going to get some sort of like infinite numbers, okay, numbers which is somehow large. So let us try for 75, okay, for 75, and then we compile. So this is going to be our last example on trigonometric functions. As you can see, so for the cos of 75, we are going to get 0.25881. Okay, so that is the correct output. That's the correct output. So we also have mathematical constants. For example, we have the pi. Okay, so let me show you how we can use the pi. So in order to get the pi, you can just get it from the math class. So math dot, we have e, we have pi, we have tau. As you can see, we have those ones. Okay, we have those ones. So we can get the pi. Let us get the pi like that. If we save, and then if you want to be a game developer, this is going to be great for you to learn. Okay, it's going to help you a lot when you are developing games. So as you can see, we get that output. The pi value for pi is 3.14159265535, and so on. Okay, so we can also get the Euler's number. Okay, Euler's number, which is E. Okay, so for those who like physics, you can get Euler's number like this, E, like that. So if we get this one, so if we try to compile and then we run, as you can see, we get the Euler's constant, which is 2.7182, blah blah, like that. Okay, so that is it about a math class. Okay, that is it about the math in Java. Okay, so those are the basic methods you can use, okay, from the math class in Java, which is provided. So for the math class, you don't need to import anything. You don't need, okay, you just use them. Okay, and in the later parts, we will learn how we can create our own custom, okay, how we can create custom methods, okay, that we can use in our code. Okay.